Good morning everyone. I am Kavita Choudhary, Senior Assistant Professor in Department of CSC, GIET. Today we people are going to discuss non-recursive predictive parsing technique of compiler. So before starting non-recursive predictive parsing, we must know about that what it is. So when a compiler enters into its second phase of syntax analysis, it parses the given input string. These parsing techniques are classified as top-down parsing and bottom-up parsing. The major difference between these are that a top-down parsing begins from the root node and it moves while scanning from left to right towards its leaf nodes. While we are talking about bottom-up parsing works just oppositely. It starts from the leaf nodes and it moves towards the root node. If we enter into the final starting symbol, that means the parsing was successful. So now switching towards non-recursive predictive parsing, suppose if I have been provided with a arithmetic expression, that is identifier plus identifier multiplied by any third identifier. For this particular arithmetic expression, we are provided with a grammar set. That grammar set actually contains grammar symbols which are separated by plus and multiplication symbols. So from this grammar set, we need to parse this particular input string. So how the processing will be? Non-recursive predictive parsing begins from the starting symbol that has been provided into my grammar set. Now this grammar set will be expanded for its respective production. Here the respective production is available as TE dash. So while deriving the next expansion, we will expand this particular node into two nodes, that is TE dash. Now we will start scanning the leaf nodes from left to right. If the leaf node symbol exists as a terminal symbol, we will simply consume it. If the symbol appears as a non-terminal symbol, we will expand that non-terminal symbol for its respective production. So starting from the very first node, that is capital T. So here T is behaving as a non-terminal symbol in the grammar given set. So now this capital T will be expanded for its derivation, that is FT dash. So now we have moved towards a level down, that is T is having an expansion FT dash. Now again scan the leftmost leaf node, that is capital F. Here this F is again behaving as a non-terminal symbol. So we will expand this symbol with its respective production. As the input string pointer is right now pointing towards the ID, so now we will verify the expansion that is available for this production. Here this non-terminal symbol F has two production. The first production is representing a sub-expression and the second production is representing an identifier. So now we will expand it for this identifier. That means F has been expanded for identifier. Now again scan this leftmost leaf node. If this leaf node comes equal to the input string character, that means we have successfully passed this input character and we will consume it. After consuming this identifier, we will move towards its sibling node. As here we see that this identifier does not have any sibling node, we will backtrack towards its previous node. This previous node is now successfully passed. We will search for its respective sibling node. Now this sibling node is T dash. Here T dash is again behaving as a non-terminal symbol. So again we will replace this T dash for its respective production. And now the input pointer has been forwarded to the next input character, that is plus. For this expansion, we did not get any sort of plus symbol for these productions. So we will replace this T dash with a null production. Now we will search for this sibling node. As its sibling node does not exist, we will move towards its parent node. Now for this T dash, again we don't have any sibling node. We will backtrack towards its parent node. Now this capital T has been successfully passed. Now we will search for its sibling node, that is E dash. E dash is again here behaving as a non-terminal symbol. That means we need to expand this E dash for its respective production. So now its production will appear as E dash plus T E dash. Now we will scan the leftmost node of my tree, that is plus. Plus is here a terminal symbol and my input character is again containing a plus symbol. If this plus symbol is matching with the leaf node symbol, that means we have successfully passed our plus symbol. Now I will switch to the next node, that is capital T. Now, as we were on the leftmost production of E dash, that is plus, for the input string, that is ID plus ID into ID, we have till scanned ID plus. Now the next symbol remaining is ID into ID. Now for this sibling node capital T, which is a non-terminal, we will expand this non-terminal symbol for its respective production. So its respective production is now F T dash. For the leftmost leaf node, that is F, again it is appearing here as a non-terminal symbol. We will replace this capital F with its respective production, that is ID. Now scan the next sibling node. As this identifier does not have any sibling node, we will backtrack towards its root node, that is capital F. This capital F is now searched for its respective sibling node. Its sibling node is T dash. So for this T dash, again as a non-terminal, we will expand its production as star F T dash. That means star F and T dash. Now we have scanned this ID with this ID, and the next input pointer is pointing towards star symbol. As the leftmost node that appears here is a star, is a terminal symbol, it is checked with the input string given pointer value. That means this matches and it is successfully again passed. When we look for the next sibling node, that is capital F, we need to expand this capital F for its respective production. So F is replaced by ID. This ID matches with my next input pointer and this is successfully again passed. Now the input string has reached to its end. That means the input string has been completed. Now look towards the parse tree that we are designing. In the parse tree, we are still left with two non-terminal productions, that one is T dash and the another one is E dash. Now for these two symbols, we need to replace them with their production values so that this parsing is successfully done. So this T dash will be replaced by a null as it is mentioned here, and this E dash is again replaced by its null. So after reaching to its last node and to the last of the input string, the parsing is successfully done. Okay. So till now we have seen that how does a top-down parsing is done, starting from a starting symbol of that given grammar set and moving towards its leaf nodes, and how that we have successfully passed the given input string. Now let's move towards the logical concept of non-recursive predictive parsing. Non-recursive predictive parsing uses the concept of predictive parsing in which all actions have been predefined by the predictive parsing program. This parsing technique uses 4 components. One is the predictive parsing program in which the logic actually works. One is the input buffer. Another, we have a stack which stores the non-terminal symbols existing with that particular grammar set. And the next, we have a parsing table and an output. How does it work? This input buffer contains the string that is to be parsed. What happens when compiler starts scanning a particular string or a program statement? That particular program statement is fed into this input buffer, and that particular string is followed by an end marker that represents that the statement has its end. Then we have the second component, that is the stack. How does this stack works? This stack actually contains the sequence of the grammar symbols with an end marker on its bottom. Now, why we have included this end marker? What happens initially when the stack is empty and we need to do a test of underflow, we have placed an end marker at the bottom of the stack. So, when the stack is initially empty, so stack stop value will represent an end marker. Next, we have the output. This output is actually the production rules, those production rules that are used for parsing that given input string. This is the parse table. This parse table is actually a two-dimensional array. This two-dimensional array is separated into 2 sections. The first part is representing the non-terminal symbols given in that grammar set. And this small a represents all of the terminal symbols that are available with the grammar set. Now let's see the logic that how actually this predictive parsing program works for this. What we have done, we have maintained an input pointer for the given input string. This input pointer will point to the very first symbol of the given input string. As we can see, like initially when we are using this input pointer will point to the A symbol. Then we have maintained a non-terminal symbol on the top of the stack. This non-terminal symbol is the starting symbol of the grammar set. Then the program logic starts. We will check until the stack is not empty. If that particular X symbol, that means if a stack stop value is a terminal or it is an end marker. This is the very first condition. If this particular X symbol that is lying on the top of that stack, if this symbol exists as a terminal symbol, we will check that whether that stack value matches with the input pointer value. If it matches, that means pop out that X from the stack and forward your input pointer. Then if this X value does not matches with the terminal value, that means we have an error. Next part, suppose on the top of a stack, if it is not a terminal symbol, that means it is lying with a non-terminal symbol. So if we receive a non-terminal symbol, now the program logic will move towards the parsing table. We will apply a condition if for this particular non-terminal symbol in the parsing table, if we have a production say as xA, y1, y2 and yk. If we receive this production, we will pop the stack. That means this capital X will be popped off from the stack, and now we will reverse the given right production and we will push the production onto the stack. That means now while pushing it onto the stack, we will be entering it as yk, then yk minus 1, then y2 and y1. why have we reversed this input, why have we reversed this grammar symbol? This grammar prediction is reversed because compiler scans always from left to right, and stack is the data structure which follows the last in first out symbol. That means when I am scanning from left, and if I will enter this string as it is, that means YK will come on its top. That means we are forcing it to scan from right, but it is not possible because compiler scans from left to right. That's why we have reversed this prediction as this one. Now after pushing this particular prediction onto the stack, the same process will repeat. If both of the condition does not match, that means we have received an error. How this parsing will end? The parsing will end only in one case, that is if we have received end marker in my input buffer or an end marker onto my stack. So now we are going to implement the non-recursive predictive parsing algorithm on this grammar set for parsing this given input string, that is id plus id into id. So now we will maintain 3 columns for this. The first column is the stack. This stack, as we have seen in the algorithm, is initially provided with an end marker. Next, we have the input string, and this input string is id plus id into id, and as we have seen that the input string, when it is fed into the input buffer, it is followed by an end marker. That means I will enter an end marker at the end of the given input string. Thirdly, we have output. This output represents that for which prediction I will be parsing the given input string. So for identifying the predictions for which we are actually filtering it, we need to design a parsing table. As we have seen that the parsing table contains a 2-dimensional array in which the left part was the non-terminal symbols. That means capital E, then capital E dash, then capital T dash, and then F. Now, this 2-dimensional array will contain the terminal symbols on the top of it, that is the second dimension. ID, this, plus, multiplication, opening parenthesis, closing parenthesis, and then the null values and the end marker. Now, we need to place all of the prediction entries into this parsing table, because these predictions which we will enter into the parsing table, these predictions will be used for parsing that input string, and that prediction will be written into the output set. So, for scanning, this identifier, that is ID, we had an expansion that is e to t e dash. You can see here that it is e to t e dash. This t is furtherly replaced by f and t dash, and this f is finally replaced by its identifier. So now for this non-terminal symbol capital E and for the terminal symbol ID, we have the initial production, that is E, T, E dash. Same way, when we want to access identifier for the non-terminal symbol capital T and capital F, the same concept will be followed, that is T, F, T dash, and for F we will use ID. Why have we not used sub expression E here? Because the input string that we need to pass, that input character contains an identifier. This production is used for sub expressions, not for identifiers. Identifier production is the second alternate. That's why we have entered the production that is from F to ID. Then when we want to scan ID from these remaining two non-terminal symbols, we do not have any production available here, as E dash is beginning with a plus symbol and T dash there is beginning with a star symbol. So now scanning towards the next terminal node, that is plus symbol. For plus symbol, we have only and only a single production, that is E dash plus T E dash. That means for this E dash we will enter E dash plus T E dash. Now for this plus symbol T, T dash and capital F, we do not have any of the productions. So now we will switch to next terminal symbol, that is star. For this star, we have again a single production, that is T dash star F T dash. That means we will place it entry T dash star F T dash. Now for the next terminal symbol, that is a round parenthesis, we need to scan. For this round parenthesis, we are provided with only and only a single production, that is a sub expression production of a non-terminal symbol, that is capital F. This capital F is again derivable by T and capital E. That means for this terminal symbol, we have production E, T E dash, T, F, T dash and F, E. I hope is it clear now that why have we used the production F with sub expression E and why we have used here the production ID. Because this ID is representing the terminal symbol identifier, and here this F with sub expression E is representing opening of a sub expression that is behaving here as a terminal symbol. Now till now we have scanned our input string on the basis of these terminal symbols. We have come with the available productions. Now what about the remaining terminal symbols? For the remaining terminal symbols, this closing parenthesis represents that the sub expression has been terminated. For terminating that sub expression, as we have seen in our last example, that I replaced this T dash by null, and at the last, very last, we replaced this E dash. I hope you remember, plus T E dash, I replaced this E dash again with a null. Why? Because we were at the end of the expression. So for this closing parenthesis, we will have two productions. One is E dash null and another T dash null. And when we have scanned our sub expression and we don't have any value, that means our next terminal symbol, that is a null value. For this null value, we have the remaining production as the same one, that is E dash null and T dash null. Now what happens if we do not have any empty string, if we do not have a round parenthesis, if we do not have a closing parenthesis, and we are provided with a single terminal symbol, that is an end marker. For this particular end marker, the same rule will be followed. Otherwise, I will replace the column. Better. Shall I continue? As the predictive parsing program says that start from the stack symbol and push the first starting symbol of a grammar set. In this given grammar set, the starting symbol is capital E. So, initially we will push capital E on the top of the stack. So, for this capital E, we will apply the same logic that check if value at the top of a stack is a terminal or a non-terminal. Here E is behaving as a non-terminal. So for this non-terminal, we will look out for a production available in the parsing table for this input character. We have a production that is E, T, E dash. That means we will write E, T, E dash. Now, for this production, as we have seen in algorithm, we will pop this capital E from the stack and we will push the right hand side production onto the stack after reversing it. So, for reversing it, pop this capital E from the stack and reverse it. Then this will be pushed as E dash T. I hope it is clear that E dash, that is YK. YK will firstly be entered and then followed by capital T. Now again check the same for the first input character, that is ID. Again, the value that is placed on the top of the stack, that is capital T. Apply the same check. Value at the top of stack is a terminal or a non-terminal. It is a non-terminal. So for this non-terminal and this input character, check a match in the parsing table. We match a check, that is T if T dash. That means we will apply the production output rule, that is T if T dash, and then we will pop this capital T from the stack and we will push the right production into it after reversing. That is dollar E dash, T dash and F. Now again apply the same rule, that is value at the top of stack is again either a terminal or a non-terminal. It is a non-terminal symbol, that is capital F. Check the production for this input character, that is ID. F, ID. We have a production F2, ID. It means again replace F, ID. Then pop this capital F from it and push that production. E dash, T dash, ID, ID plus ID into ID and dollar. Again check the value that is placed on the top of a stack, that is ID. Does it matches with the input pointer value ID? Yes, it matches as it is a terminal symbol. Then pop both, that is value at the top of stack and the input pointer character from the input string. So we will receive now dollar E dash T dash and plus ID into ID and mark. Now my input pointer has been forwarded. So now my input pointer is pointing towards plus. Now I will again check value at the top of the stack, that is T dash. It's a non-terminal. Check whether it has a production for this input character T dash plus. No, it does not have any of the production. That means this T dash will be replaced by a null. So dollar E dash plus ID into ID and end mark. My input pointer is again on the same symbol, that is plus symbol, and on the top of the stack I have E dash. So for this E dash, check a production for the plus symbol. That means E dash and plus. E dash plus T E dash. That means now pop this E dash from the stack and push E dash with the production plus T E dash in reverse. That means dollar E dash T plus, then plus ID into ID and mark. Current input symbol and the value at the top of the stack. The value at the top of the stack is a terminal symbol. So this terminal symbol is now checked for its matching. This matches, that means pop both of them from the input buffer and from the stack. So now we have dollar E dash T ID into ID. Now my input pointer has been forwarded and it is pointing now towards ID. And the value at the top of the stack is capital T. So for T and ID, we have a production T say FT dash. That means dollar E dash T dash F, and this is ID into ID and marker. Now again value at the top of stack is a non-terminal symbol and search for the current input symbol capital F and ID. Capital F and ID, we have a production F to ID. That means F to ID dollar E dash T dash ID into ID with an end marker. This is the current input symbol. This is the value at the top of the stack. So now this is a terminal symbol. It will be checked for this current input symbol. They both match. That means pop both of them from the stack and from the input buffer. So now I have the next result, that is dollar E dash T dash star ID and mark. Now again the value at the top of the stack is T dash. So for this T dash and this current input symbol, that is star, T dash with a terminal symbol star, we have a production T dash to star FT dash. That means star F T dash. We will pop this T dash from the stack and we will push the production, that is T dash F star, E dash, then T dash F and star. Now again the value at the top of the stack and the value available at the input pointer, they both match with each other. They both match with each other, that means pop it from the stack and remove it from the input buffer. Now from this step we are now switching to the next step. At the top of the stack now we have, I am writing the same step again so that you people can link it. E dash T dash F star ID dollar for a production, that is T dash 2 F T dash. I hope you people are able to link with this and this. Now for the value of the top of the stack, it is a terminal. So this terminal is matched with this input character. They both match, pop both of them. Now we have dollar E dash, T dash and F, here ID and dollar. Now for the value at the top of the stack, that is capital F, check a production for ID. That means F and ID. We have a production F2 ID. That means we need to replace with F2 ID. That means now my stack will have dollar E dash, T dash, ID and dollar. Now value at the top of stack is again a terminal symbol and the input character is again a terminal symbol. They both matches as identifier, pop both of them out. Now we have the stack value as dollar E dash, T dash and here dollar. Here we can see like we have received an end marker in the input string, but parsing is still not complete. The reason? Because stack still has two symbols on the top of its end marker. That means still we need to replace these non-terminals to make this parsing as a successful one. So for this T dash and end marker, we have the production as T dash null. That means T dash null dollar E dash end marker. Now for this E dash, again search for this end marker symbol. That means E dash and end marker, that is again a null. That means E dash with null, dollar and dollar. If we have received at the top of the stack as end marker and at the input buffer an end marker, that means successful parsing. So now we have seen that how a non-recursive predictive parser program parses a given input string from the given grammar set. As we have seen that all of the strings that have been parsed, we have used an output production rule, and this production rule we have taken from the parsing table. So now we need to learn that how can we construct the parsing table. So for construction of this parsing table, we use two functions. The first function is a first function and the second one is a follow function. So what is the first function? As its name defines, first means the symbol by which the grammar is beginning in a production. As we have seen that first of alpha means a set of terminal symbols which occur as first symbols in the string derived from that symbol. What are follow? Follow means as again the set of terminals which immediately follow the given symbol. That is a non-terminal symbol. So, if you people want to see a simple example, we can see for a given grammar set that S is equals to alpha, capital A, beta. Here, capital S, capital A and beta are behaving as a non-terminal symbol, and alpha and A, they are behaving as terminal symbols. For this production, here a terminal A is in follow of capital A. Why? Because follow means the character which is immediately following the required one. So, follow of A will contain the character or the terminal symbol that is immediately following it. That means small a. Now, for each production that has a form A to alpha in a grammar, we need to do the following things. For each terminal, that means for each terminal A, in first of alpha, add this production into the parsing table for alpha. That means the first terminal symbol that we will be going to receive will be entered as the first symbol. If an end marker, that means, if an empty string is in first of that alpha set, then for each terminal, means for each terminal B, that terminal is the another terminal. Then for each terminal B, in follow of this capital A, are you people getting? Like if an empty string is in first of alpha, then for each terminal B that is existing in follow of A and A has a null production, then we will make an entry that is M A comma B. That means for this A comma B, we will make an entry of this one. If null is in first of alpha, then and dollar is in follow of A. If null is in first of alpha and dollar is in follow of A, then add this capital A production with null to the parsing table for this end marker. The third rule is, if after performing the all above rules,